Hey, good morning, students. So today we're going to go over the Lewis Structure Lab. And so for this video, we are going to be looking at the nitrogen trichloride, the NCl3. So to be able to start this, we're going to be looking at step 1 on the procedure, which is going to be looking at calculating how many valence electrons are in the molecule. So the way I like to do this, I like to make myself a chart and then write how many valence electrons are in each of the atoms. So to be able to do that, we're going to look at each atom separately. So first is nitrogen. So looking at the periodic table over here, we can see that nitrogen is in, I like to determine how many valence electrons nitrogen has by what column it's in. So if we look at this, it's 1, 2, 3, 4, 5, and then I'll put the 6, 7 just for later. So as we can tell, it's in column 5. If we don't look at the D section, the d orbitals, then it should be 5, meaning it will have 5 valence electrons. So we come back over here, we put in our 5 valence electrons. Now we're going to be looking at Cl and determining how many valence electrons that one has. So for Cl, we look over here, and it is right here. So that shows us that we should have 7 valence electrons. So we write that over here. Okay, so nitrogen 5, Cl 7. But as we can tell, there are 3 Cl's in our molecule. So we have to take that into account when we're trying to find the total valence electrons in the molecule. So nitrogen is 5, Cl 7, and then to take into account those 3, we're going to times that 7 by 3, giving us 26 total valence electrons. Okay, so knowing that, we go to step 2, we're just going to be looking at the atoms and determining their conductivity. So we have nitrogen and we have Cl. So to determine which one's going to be in the middle, we're going to be using electronegativity, as well as seeing which one can make the most bonds. So between nitrogen and chlorine, if we look here, chlorine is right here. So it's really close to, the top right, showing that this is very electronegative. Nitrogen is 2 away from the right top, showing that it is less electronegative than Cl. So when looking at the conductivity, nitrogen should be in the middle of if we use the trend of electronegativity. Now on step 3, we are now going to make bonds between each of them. So nitrogen, Cl, Cl, Cl. Okay, and I like to keep track of my electrons. So over here, I'll be looking at this total, which was 26. And then I'm going to look at how many I used in the bonds. So 6. So that means that I have 20 electrons left over. Now with those 20 electrons, we're going to be now moving to step 4, which is going to be putting in the lone pairs. So for the lone pairs, we're going to put them on the exterior atoms first. So 1, 2, 3, 4, 5, 6. So 6 around each of the Cl's. And then why we put 6 around each of the Cl's is because we want to complete the octet. All of the atoms are most stable when they have a completed octet. So that way they fill the orbital. Okay, so looking at that, we have 6 around each of them. That means that we just use 18 electrons. So 18 electrons used. And so the leftover that we now have is going to be 2 electrons. And so we can use those to now fill the central atom. So we put them right there. Now we're going to look at each of them and make sure that we have a full octet. So over here we have 2, 4, 6, and this bond counts as 2 as well. So that's going to be 8. So it's 2, 4, 6, 8. And then looking at nitrogen, it's 2 in this bond, 2 in this bond, 2 in this bond, and then 2 in the last one. So that's going to be 8 as well. So this is going to be our Lewis structure. So now that we have our Lewis structure, we're going to use this to determine the geometry. Put a copy of it down here. And how we're going to do this is we're going to be using the table that was given to us in the procedure. So over here, we have the number of electron sets. So on here, we're going to need to figure out how many electron sets there are. So over here in nitrogen, there's going to be one here, which is the electron, lone pair of electrons, one here, which is the chlorine, and one on each of the other chlorine. So those are all going to be electron sets. So 1, 2, 3, 4. So that leads us to this. So if we're looking for electron geometry, that means that's going to be tetrahedral. Now, if we're looking for molecular geometry, it's a little different because you have to take into account the lone pairs. So on here, we can see that this group, one second. This group here is a lone pair. Although it's an electron set, it's still a lone pair, so that means we have one. So now, for molecular geometry, we're going to have that trigonal pyramidal. Okay. So now we have our electron geometry and our molecular geometry. So to be able to show you guys the 3D model, I decided I'm going to be using an online app that makes it possible to look at the 3D model. So I'm going to be using this one. So this one we just closed the pop-up. So as you can see here, they already have a molecule set up, and you can look at it in 3D, which is really nice. That way you can look at the different angles. It's a little different than having it in your hands, but it still is quite helpful. So I'm gonna get rid of this. I'm gonna put an R molecule, which is nitrogen, and then 3 Cls. And then I'm gonna draw a bond between each of them. Now my molecule looks a little weird, so I'm gonna use this little broom here to clean it up. And it looks nice now. So now I'm gonna go from 2D to 3D. Okay, and if we look at our molecule, just from this angle, it looks like it's flat. It's just a triangle. But then when I rotate it, it looks a little different in 3D. It looks like it looks like there should be another group here, which that would be the lone pair. So that's why the molecular geometry is trigonal pyramidal rather than just trigonal planar. And so that should cover our nitrogen trichloride.